you see problem 3, force acceleration 2, and I can see, you see, among the very challenge problem in force acceleration. So we have two wheels, AP and OG as shown, and the flywheel OG unbalanced and clockwise rotation, so as shown there. And they also give the angular velocity for this flywheel is 4 radian per second, so also shown in the finger. And the question is, did the wheel AP slip or not slip? So that is the questions. So not a lot of information, but then you see basically slip or not slip is all about the force acceleration method for today class. And we can have properties, as you can see there. They give R, the weight, and then we find out the mass for wheel AP is 5 slugs, and then for flywheel OG equal to 20 slug. And the wheel OG, and you can see rotation about the axis perpendicular to screen and go through O is fixed, so it will be Rafa. And wheel AP, it both rotation to the right and also translate to the right and rotation clockwise, so you can have that is a GPM body. So that too. And with after classification, we can go ahead to draw the diagram for each of them. So let's draw the diagram for wheel AP. Draw wheel AP, and that is one wheel, so you can have free body diagram equal to kinetic diagram. Free body diagram equal to kinetic diagram. So wheel AB, let's draw that wheel. Make them equal, and we have an inclined surface. No, not inclined, the horizontal surface for AP. And we have point A there, and point A, and then you can see this is a balance wheel, so A is actually the center of mass for this body. So go ahead to draw the free body diagram on the right side with X and Y. So we have the weight going down, and that one is 161 pounds. And if we cut that tension of the cable, so we can replace with the tension of the cable, and it will be hook through A, so you have tension of the cable. At the point of contact P, there, we have the normal force going up, and we also have a friction force, so we don't know the direction yet, so we can assume any direction. Let's assume go to the left. So that's all I think we have for the free body diagram for wheel AP. And now for body AB is a GPM body, so and it translates to the right and clockwise rotation. So and A is always parallel to the horizontal surface, so we all have MAGX. In this case, actually let's write down here, it's not really an A, but as you can see that it's MAAX, because the center of mass in this case is A. And the mass here is 5, so it will be 5 AAX. No MAAY, because that A don't jump up and down, so you don't have that work component. So only two terms in here and clockwise rotation, so you have IG alpha, in this case IA alpha. So we have, what do we have? They give us 15, so equal to 15 slug feet square times alpha. So we can go ahead to write three equation for this one. So let's start with the sum of all the force in y direction to find out the normal force, and MAA in this case, right? MAA y. So from that we can have normal force minus the weight 161. So we have N equal to 161 pounds. So that is the y component. For the x, sum of all the force in x direction, MAA x. So from that we can have, okay, T go to the positive, and then negative friction force, what else, equal to MAAX. So we will find AX. So because that already done for this equation, right? Equation in y direction, we call this one have three unknowns in this, so we call that equation 1. And then we will have the moment equation. I'm going to take moment about A, center of mass. You may check the solution on the PDF file to find out the another way to take moment about the point of contact PC in here. You can take moment about point of contact CPC. So it will be equal to IG alpha. So from that you can have what here, MAA. So weight go through that to A, so it will be 0. T go through A should be 0, and then we have friction force, and the radius for this one equal to 5. Radius 5 feet, right? So from that we can have friction force. Let us, because they clockwise, so let assume clockwise position, rotation is positive. So let's do that. So we have about A, so you have friction force, so it will be friction force times 5 feet, right? And that's it, equal to the left side, the right side, IG alpha, so it will be 15 alpha. Number 2, equation 2. So now we have two equations. Let's see how many unknowns we have. We have tension 1 unknown, friction force 2, and then we have AX 3, and then we have alpha E4. So two equations, 4 unknowns. So we cannot solve. How can we do? There are multiple ways. You have another diagram, right? Another body. So you draw another one. That is first. We also assume something. In this case, as you can see, the question also asks, does the wheel AP slip? So we may assume something in there so that you can reduce the number of we can put more equation in. So in this case, let's assume and always assume no slip first. If you don't recall, go back to problem 4 of force acceleration 1 when we deal with slip, no slip wheel. Very important, go back to that one. So let's assume, always assume first in no slip. Don't assume slipping first in this time of problem. So assume no sleep will, and in this case the will AP. We OG already Rafa, so nothing talking about sleep or not sleep in there. So from that, when it no sleep, what do we have when the wheel is no sleep? If you don't remember, go back to the note number 2 of force acceleration 1. We talking about that. So friction force, or can even go back to rigid body kinematics 2. You have that as well. So friction force will be less than or equal to mu sub Sn. And we will have equation when it no slip. We have it AX at the center of the wheel, AA. In this case, in X direction, it equal to alpha R, equal to alpha. In this case, let me put the alpha here because we have 2 alpha for 2 bodies. So let's put the alpha for this body is alpha AP. Everyone see that? So that one is alpha AP. It's not the same alpha for both bodies. The angular acceleration are not the same for both bodies. So in here we have AAX equal to alpha AP times the radius AP. So what does that mean? I have AX equal to, so the center acceleration at the center, it will be equal to radius 5, so 5 alpha AP. So we have another equation here, so we can plug in. You can plug in the number 1, number 2. So we can have, now we can simplify, so plug that in. Plug 3. So get 3 to 1 and 2. Now we can have the equation is become, you have 2 equation become, equation 1 become T minus FF equal to 5 times 5 alpha AP, and that is 25 alpha AP. And then the equation number 2, we will have FF5, so it will be 5 FF equal to 15 alpha AP. And this is 2 equations. How many unknowns? You still have T, friction force, because as you can see, no slip wheel is FF less than or equal to mu sub Sn. It's not equal, so it an unknown. Friction force is an unknown. And then alpha AP, you still have 3 unknown and only 2 equations. After we make assumptions of no slip. So with that, how can we do? We have another diagram. So that will be the next video. Continue for this problem that we will draw the diagram for OG and then see how many unknowns more introduced and how many equations we can get, and we can continue from there.